guys. I'm Derrick. Thanks for the introduction. I want to talk to you about 3 things about artificial intelligence today. Don't worry. My goal is 1, for you to understand what artificial intelligence is. 2, for you to understand what it can do and kind of what it can't do. And 3, then what are you going to do about it? So we'll try and keep it brief. And I want to say, here's kind of my other agenda. What do you want to not do? Don't scream fire. Don't be, fire, artificial intelligence is going to kill us all. Not yet. Maybe. I'll come back and talk again if the singularity is coming. But it's not going to kill us yet. It's not going to destroy all our jobs. But we also can't ignore it and be passive, because it is going to change things. And I'll try to be very clear about that before today is over. You can understand it. You can understand it. You say, well, I can't understand all that. I don't know all that fancy computer stuff. You can understand what artificial intelligence is and what it's doing. So, and then you can relate it to your world. And that's what Rob's challenge was. It's so important that we do this, that we figure out how this relates to our world, because our industry will be impacted. So, basically saying the same thing. So what are we not going to talk about? I want to tell you what we're not going to talk about today, because there's this kind of a confusing space. We're not going to talk about what's called superintelligence. There are other forms of superintelligence other than this machine learning stuff, this programmatic machine intelligence. These advanced networks, whole brain emulators, human brain augmentation, that kind of stuff. We're not going to talk about that today. It's kind of, I mean, I'll just give you the short version and say there's stuff going on here, but it's pretty far out in the future. There's nothing immediately impacting our industry in these spaces. We're going to talk about programmatic machine intelligence. So what is AI, or this programmatic machine intelligence? What is it? It is this. You need to understand, it's that. It looks like that. It's hardware, it's software, it's electricity. That's what it is. It's that. It's not some human-looking faced robot that walks around and talks to you. It's that. That's artificial intelligence, okay? Cool? All right. How is artificial intelligence different from other computers? Isn't it, so it's just a computer. It's a bunch of server banks, right? It's different in that it mimics human brain structures, either actually kind of almost literally in terms of the way it tries to replicate those structures, or figuratively, in part, but not in total, because we don't understand how the brain works. I mean, I'll tell you, I've studied a lot of neuroscience. We don't understand how the brain works. The majority of how our brain functions from a neuroscience perspective, we do not understand. So we're not replicating that because we can't, because we don't know, okay? But we are replicating functions and structures of the brain in part, and that's what makes us unique. When you look at a computer over here, it doesn't do that. It's a universal Turing machine. It doesn't replicate or try to do what the brain does. It does something different. But these artificial intelligence systems, what makes them different from a computer that sits on a desk is they do try to replicate and mimic what our brains do. Okay. Yeah, to get through this conversation, you got to get a little technical for just a minute. We got to understand what a neural network, genetic algorithm, and machine learning are, okay? Don't worry, it's not going to be bad. There's a whole bunch of stuff here, but I'll try and make it simple. On the one side, you have these 2 machines that work with each other, okay? There's basically 2 machines that work with each other. And on the one side, you have what's called a policy network, okay? And this policy network, if it's a neural network, it works one way. And if it's a genetic algorithm, it works another way. And there's actually 5 different types of these. We don't need to get into all those details. The most basic explanation is this policy network has a model, okay? A model of how to do something, okay? And, or it has a set of rules, like an algorithm, okay? And it goes out and it tries to find more or better ways to do that. And it submits that to a value network or a fitness function. In the case of a neural network, it submits it to a value network. In the case of a genetic algorithm, it submits it to a fitness function. And that decides if what it came up with, this value network or fitness function, decides if what this came up with was a good idea. And it says, yeah, it's a pretty good idea. Not a perfect idea, but a pretty good idea. Let's add it temporarily to the rules. to the algorithm, okay? And it's added temporarily because just like your brain, when you learn something new, you add it to your brain, right? But you don't think that that's universally true forever. New stuff comes along and you adjust what you learned. That's what these systems are doing, okay? That's what they're doing. They're evaluating this and going, yeah, it's a pretty good idea, let's put it here, but tentatively, depending on context, okay? That's what these systems do. Okay, so what's in a name? Before I even go on further, I'm going to change the name. I'm no longer going to call it artificial intelligence for the rest of this discussion, because that carries a whole bunch of connotations with it that you guys kind of worry about a lot of times. Well, I used to worry about. And I want to change the term to SRS, Specific Reasoning System. So we're not going to call it GAI or AI or neural networks. We're going to call it Specific Reasoning Systems. That's just for this discussion. There's no such thing as a specific reasoning system. I made that term up. But I'm going to call it that because that's what these things are doing. These things right now are specific reasoning systems, meaning they operate within a space. So if they play chess, and they don't play checkers. Okay? Or if they do a particular type of analysis of a market, if you've got a neural network that's doing a predictive analysis of a market, it does the analysis of the market. It doesn't do analysis of blood. Okay? They're not generally purposed things. They're very specific things, and they do a specific kind of reasoning. So I'm going to call them from here on out specific reasoning systems, because I think that's what's going to help you guys start to think about the way they operate. Okay? Another important piece of background you need to know is, are they better than you, or are they faster than you? Yes and no. They are faster than you, sort of. A computer can turn a transistor on or off 1 billion times a second, okay? But it does it in a linear manner, meaning one transistor after the next, but 1 billion of them can be switched in 1 second. That's a lot fast, okay? You are only capable of firing your neurons at the most 1,000 times a second, okay? So it's got you beat, hands down, right? But you can fire thousands of neurons, maybe even millions, simultaneously, 1,000 times a second. So what is happening with you is you're doing parallel processing, and it's doing linear processing. It's much faster at linear processing than you are, but it can't do parallel processing. The AI still can't do parallel processing. So why does that matter? It matters because once a system, once an SRS becomes good at something, then it goes really fast. And that's where you get this concept of the acceleration of change. Everybody's talking about it's going to happen so fast, it's going to change so fast. It's because of that. But once they learn, once an SRS learns how to do something, some kind of thought within a narrow band of parameters, then it goes fast. Okay, so understand that. What's the limiting factor? What can these SRSs not do? Well, the main limiting factor, if there's one limiting factor that all these SRSs stops them from performing and functioning, or enables them performing and functioning, it's that. It's enough clean data in a discrete space. If you've got a SRS, whether it's a genetic algorithm, neural network, doesn't matter, and it's got enough clean data in a discrete space, it will beat the human. Okay, and I'm going to give you examples of what that looks like. But that's what you got to watch for, and I'll show you. All this will come together with some practical advice at the end, okay? So we've got the speed issue, we've got the discrete data issue, we understand basically what these systems are doing, right? So let's take some look at some specific examples of what these systems are doing. Some things that you're pretty familiar with, spam and filters. Like spam filters are done by AI, okay? Those are AI systems. Generally, they're neural networks. ImageNet. You guys may not be familiar with ImageNet, but this is important for you to know. It might sound like it's kind of just, okay, this is a game the computer's playing, but it's important. There's this set of images that exists called ImageNet. It'll be, 100 pairs of pants or 1,000 pairs of pants, right? And I clearly don't have dress pants on today, right? And if you look at Alex, you'll say, what kind of pants? Khaki pants, right? Well, there'll be all these pants in there. And a human can look at this image bank of 100 or 1,000 images and get about 95% correct, like naming the type of pants. But computers now, these SRS systems, if they focused on pants, not cats, but pants, and if you train the neural network for pants, it can beat the human, okay, in spotting what type of pants it is. That's the important thing. It can recognize that. So, okay, so what? What does that mean? Well, for example, if you're talking about a finance transaction, you're looking at accounts payable, accounts receivable, a debit, a credit, and it looks at it and it recognizes the type of transaction, it can process it. That ImageNet matters because it can be trained to recognize any image. An image, for example, of a source document. So that capability matters. Facebook recognition is very similar. The Facebook facial recognition is over 95% accurate, better than humans. Translation, voice command reaction. I'll tell you right now, it's not as good as humans. Humans are still better at translation and voice command recognition than computers. Computers are catching up, but humans are still better. Driving, everybody talks about this example of driving. There's driverless cars, right? Everybody knows about driverless cars? Are there going to be driverless cars in Manila soon? You're laughing. You're right, they're not. But there are going to be driverless cars, and they're going to be on NLEX and SLEX. They're just not going to, and you're going to turn them on like you turn on cruise control. And it'll take over because it's easy. But when you're in Metro Manila and you got, you know, the peanut vendor to run over and 7 guys trying to cut into your lane, your artificial intelligence is not going to be able to handle that just because the infrastructure won't be able to handle that. But the mundane driving tasks are going to happen soon. And you're going to go from cruise control to artificial intelligence control on the easy road conditions. Prediction and modeling. This is, and by the way, all those are about differentiation and recognition. I want to, those words are big for a reason. If you're doing a job that's predominantly about differentiation or recognition, that will fall to AI. Prediction and modeling. Prediction and modeling is another thing that AI does well, or SRSs do well. Internet search responses, that's prediction and modeling. You put in a string, it predicts what you really want to know, and it spits back a response. Music shopping, wine shopping, all those kinds of things. Games beyond computational power, such as the Go game. I won't go into that Go game, but it's a very interesting story. Investment fund analysis, traffic planning, all these things are the kinds of things that happen with prediction and modeling. So what do I mean by that? What I mean is the SRS is fed enough data, and it looks at this data, and it sets up a model of the way something functions. Like a fish tank. It could set up a model of a fish tank, and then you say, what if I drop 1 drop of acid in there? It'll tell you what's going to happen, right? It sets up a model and predicts, drop 1 drop of acid in, this fish will live, that fish will die. It knows because there's enough good data in the system, right? But that gets big, right? There's a speaker you guys will eventually, I'm sure, hear, who'll tell you about how he modeled the traffic for Singapore, right? Same kind of thing, exactly. Okay. Here's a specific example that will help you understand. This is the exact same technology doing 2 different jobs, okay? One is the X-ray technician. And so in customs, they look at these boxes that come off the boats, and they do X-rays, and they look at the X-rays, and they look for contraband, right? And if you can spot the contraband, the X-ray technician spots the contraband, then they grab that box and they take it out. And well, now they have these AI systems that can do that instead of doing like 1% or 5% of all the incoming boxes, they can do 100% of the boxes, 100% faster, and 100% more accurate than the technician. That guy's out of a job. He's out of a job. He no longer is going to stare at X-rays and spot contraband. The AI will do it. And that's a perfect example of a person who's lost their job because, listen carefully, the predominant aspect of the job was something AI could do. Okay? Now, here's a person who didn't lose their job and won't lose their job. This is an oncologist, same exact technology. There's now AI systems that can look at X-rays of lungs and locate malignant tumors better than the best panel of doctors out there, the best panel of oncologists. AI systems are better, simply better. And these are doctors, okay? Does that put the doctor out of a job? No, because that's not the predominant thing the doctor does. The doctor doesn't sit there all day long looking at X-rays. It's just one piece of what they do. So that job has been augmented by AI, and that's what you need to know. Will my job be augmented by AI? Well, if AI does a piece of what you do, then yes. If AI does most of what you do, then it could put you out of work. Okay, so this is kind of what we're worried about, right? We're worried about these guys. I want to tell a very specific story for obvious reasons here. So any job that can be documented in a 3-ring binder where most actions and reactions are predefined and it requires little physical dexterity, that job is something that can fall to AI. But that person there that you see, that gal there, I'm not talking about her. Because everything she does, you got to look at the whole job. Everything she does is not documentable in a 3-ring binder. Linguistics is not documentable in a 3-ring binder. If she doesn't talk to anybody, if all she does is hit the keyboard, yes, that will fall to AI, and relatively soon. But you can't take her linguistic capability and yet do that with AI. Once AI can do the linguistic capability part of that job, then yes, it'll fall to AI. So that's the thing to look at, is anything that can be documented in a 3-ring binder, and truly it just requires, there's no headset on her. If there's no headset on her, then there's gonna be invasion of AI there. Another example here, number 2, any job that predominantly involves a set of rules with moments of analysis or simplistic decision-making, accounting. I have bad news. If you got brothers or sisters who are enrolled in accounting courses, tell them to change. There's only going to be controllers and CFOs left. This is 5-10 years from now. There's nothing but controllers and CFOs left. Everything's going to be done by AI because it's just a bunch of rules. And yeah, it doesn't belong in 3-ring, but the rule set, once the SRS knows the rule set and the SRS can recognize all the source documents, that's it. It'll do the job. So those things are important things to understand so you guys can think about where is AI going to invade. I hope that helps. I gave you a big long list. You guys can digest this later. If you want a copy of this presentation, you can have it, no problem. You can digest this later, but I'll just race through this and then take whatever questions you got. I'll get practical advice first. Office support jobs are definitely at risk. Manufacturing, non-high dexterity. If something's artful, it won't yet be done by AI, but non-high dexterity. HR filter job applications, for example, a lot of medical space stuff, security stuff, physical and network fraud, that kind of stuff. Transportation, logistics, both the planning and the execution. It's very, very analytical, very reasoning activity, right? Scheduling, staffing, resource optimization, bookkeeping, accounting, routine legal work, routine journalism. This is interesting. You're going to start reading articles about the weather, sports, markets that were written by computers. They're written by AI, not humans. Very soon, all weather, sports, and market reports will be written by AI. Customer interactions, especially non-voice. Those chatbot things, they're real, they work, and they're getting better and better. And then there's stuff that's seemingly cerebral work that the SRSs or the AIs are doing. Diagnosis and prognosis, I gave you an example of that earlier. Modeling and analysis, research. Like literally 10, 20 years from now, colleges will not do research. They won't. It's just too slow. The SRSs will do all the research. It's a very, research, if you've done it from an academic perspective, is a very mechanical process, frankly. And it can be done far faster by an SRS. Experimentation, the participation experimentation. A lot of experimentation is starting to be done by SRSs. And coding, you got to know math, not because you're going to do math at work, but because you got to understand the math that the spreadsheet's doing. You got to know coding because you got to understand what the SRS is going to do. The SRS, they're going to code. You don't have to learn to code so you can code. You got to learn to code so you understand the code that's being written. So those are all the kind of things that SRSs are moving into right now. Oops, well, let me go back. So I have just one piece of so what do you do with all this, right? Let's distill this into an action. What are you going to do with all this? One, understand this. AI is the new computer. Your computer is about to become a calculator. Right? Do you still use calculators? Yes. But not real frequently, right? You're going to use computers, but not real frequently. Your computer is about to become a calculator, and AI is the new computer. You need to learn AI. You need to learn to work. Imagine if 20 years ago you said, I'm not going to learn computers. I don't care. I'm not going to learn it. Where would you be today? Right? If you say, I'm not going to learn about AI, You're going to be in the same place 20 years from now, maybe 10. Okay? You got to learn about AI. It's your new computer. It's your new tool. It is a tool. Grab it, adapt it, know it, right? And if you don't, 20 years from now, I promise you will not be relevant in the workforce. Okay? Even plumbers will need to use AI. That's the first piece of advice. The second piece of advice is look when you hear articles and stuff being written and you're wondering, what does this mean? Look at the type of thinking that's going on from the AI. Look at what kind of prediction and differentiation and reasoning, those three words, prediction, differentiation, reasoning. Look at what prediction, differentiation, and reasoning the AI is doing and ask yourself, strip it down from the details, look at the prediction, differentiation, and reason it's doing and ask yourself, does this job have the same prediction and differentiation and reasoning? And if this job is 90% this kind of differentiation or this kind of reasoning, then this job is at risk. That's how you figure it out, okay? And the third thing is, as Rob points out, we have to adapt. We have to adopt and adapt to this. We can ride this wave or we can get crushed by this wave. We must ride this wave. We must move into this space. So move your labor toward the work that will be enabled by AI instead of the work that will be destroyed by AI. There you go. That's my advice. What questions can I answer?